Hello and a warm welcome to Gemology 101, Sparkle, Science, and Stories. I'm your guide on this illuminating journey into the world of gemstones. I'm genuinely excited to have you here, and I can't wait to dive deep into the fascinating realm of gemology with you. So, what can you expect from this course? We'll start by understanding what gemology is and why it's such a captivating field. Gemology isn't just about shiny stones. It's a blend of science, history, culture, and art. Ever wondered about the difference between a ruby and a sapphire? Or why emeralds are green? We'll delve into the properties of various gemstones, exploring their physical and optical characteristics. Gemstones aren't just beautiful. They carry stories, myths, and legends from ancient civilizations to modern times. We'll journey through time, understanding the role of gemstones in shaping cultures and traditions. This is where we get a bit technical, but in a fun way. We'll explore the geological processes that lead to the formation of gemstones and understand the science behind their mesmerizing colors. Through interactive assignments and quizzes, you'll get a chance to apply what you've learned. Whether it's identifying a gemstone or understanding its value, you'll gain practical skills that go beyond the course. Now, a bit about the course structure. Each section is designed to be engaging and informative. There are video lectures, reading materials, quizzes, and hands-on assignments. I encourage you to participate actively, ask questions, and share your insights with our community of learners. Whether you're here because of a passion for jewelry, an academic interest, or just out of sheer curiosity, there's something in this course for everyone. By the end, I hope you'll look at gemstones with a new perspective, appreciating not just their beauty but the incredible stories they carry. So, are you ready to embark on this sparkling adventure? Grab your magnifying glass, put on your explorer's hat, and let's dive into the dazzling world of gemology together. As we embark on our journey through gemology, it's essential to lay a solid foundation. And that begins with understanding. What exactly is gemology? Gemology, at its core, is the science, art, and study of gemstones. But let's unpack that a bit more. Gemology delves deep into the physical and chemical properties of gemstones. It's about understanding how light interacts with a gem to give it that brilliant sparkle, or why certain minerals impart vivid colors to some gems. It's a field that intersects with geology, mineralogy, and even physics. Beyond the scientific attributes, gemology is also about the art of cutting, shaping, and enhancing gemstones to maximize their beauty. It's about understanding how a rough stone, seemingly ordinary, can be transformed into a dazzling jewel. Gemstones have been revered across civilizations, from ancient empires that saw them as divine gifts to modern societies that use them as symbols of love, power, and status. Gemology, therefore, also touches upon anthropology, history, and even folklore. Gemologists use specialized tools and techniques to identify, grade, and evaluate gemstones. They can distinguish between natural and synthetic gems, detect treatments, and even appraise their value. Now, you might wonder, why is gemology important? With the jewelry market flooded with synthetic gems, treatments, and imitations, gemologists play a crucial role in ensuring that consumers get genuine products. They help in certifying the authenticity and quality of gemstones. By studying the historical and cultural significance of gemstones, gemologists help preserve stories, traditions, and heritage that might otherwise be lost. The gem and jewelry industry is a multi-billion-dollar sector. Gemologists ensure fair trade, ethical sourcing, and accurate valuation, which is vital for the economy. For many, gemology is not just a profession but a passion. It's about the joy of discovery, the thrill of unearthing stories, and the satisfaction of understanding the world a little better. To sum it up, gemology is a multifaceted field that sits at the intersection of science, art, history, and commerce. It's about understanding the Earth's treasures, both in terms of their physical attributes and the stories they carry. Whether you're here to become a professional gemologist, make informed jewelry purchases, or simply satiate your curiosity, Understanding the essence of gemology is the first step. Now, we're diving into a topic that's not only fascinating but also incredibly relevant in today's gem and jewelry market: the distinction between natural and synthetic gemstones. Natural gemstones are minerals or organic materials that have been formed in the earth over millions of years without any human intervention. These gems are created due to various geological processes, such as intense heat and pressure, mineral-rich solutions, or even biological processes in the case of organic gems like pearls and amber. The allure of natural gemstones lies in their uniqueness. No two natural gems are identical, each bearing its own set of inclusions, colors, and characteristics that tell a story of its journey from deep within the earth to the surface. On the other hand, synthetic gemstones, also known as lab-grown or man-made gems, are created in controlled laboratory environments using advanced technological processes. These processes either replicate the conditions under which natural gemstones form or use alternative methods to achieve the same crystalline structures. It's crucial to note that synthetic gemstones are not fake or imitation. They possess the same physical, chemical, and optical properties as their natural counterparts. The primary difference lies in their origin and, often, their lack of natural inclusions or imperfections. Why the distinction matters? Natural gemstones, due to their rarity and unique characteristics, often command higher prices than synthetic ones. Knowing the difference can significantly impact the valuation and pricing of a gemstone piece. Synthetic gemstones offer an ethical alternative to natural gems, especially when considering issues like conflict diamonds or the environmental impact of mining. Transparency is crucial. Consumers have the right to know the origin of their gemstones, whether they're purchasing a rare natural sapphire or a lab-grown ruby. Differentiating between natural and synthetic gemstones can be challenging, especially with advancements in gem-producing technologies. However, trained gemologists use a range of tools and techniques, from microscopes to spectroscopes, to identify telltale signs of a gem's origin. For instance, certain types of inclusions or growth patterns might be indicative of a synthetic origin. Conversely, some natural inclusions or unique characteristics can confirm a gem's natural origin. The world of gemstones is vast and varied, with both natural and synthetic gems offering their own set of advantages and allure. As we progress in this course, we'll delve deeper into the properties and characteristics of both, equipping you with the knowledge to appreciate, evaluate, and make informed decisions about gemstones. Remember, whether natural or synthetic, every gemstone carries its own sparkle and story. It's all about understanding, appreciating, and choosing what resonates with you. Now, our focus is on some of the most popular gemstones that have captured human imagination for centuries. We'll delve into their unique properties and understand what makes each of them so special. Diamonds form deep within the Earth's mantle under extreme heat and pressure. Diamonds are composed of carbon atoms arranged in a crystal lattice. Known for their exceptional hardness, diamonds are a 10 on the Mohs scale, making them the hardest known natural material. Their brilliance and fire result from their high refractive index and dispersion. Often associated with love and commitment, diamonds are a popular choice for engagement rings. Rubies: they are a variety of the mineral corundum, colored red by the presence of chromium. With a Mohs hardness of 9, they're durable and long-lasting. Their deep red hue can range from pinkish red to blood red. Symbolizing passion and protection, rubies have been revered in many cultures as stones of royalty. Sapphires: also a variety of corundum. Sapphires get their blue color primarily from iron and titanium impurities. Like rubies, sapphires have a Mohs hardness of 9. While blue is the most popular color, sapphires come in almost every hue except red. Representing wisdom and nobility, sapphires are often associated with the divine and are believed to bring protection. Emeralds: belonging to the beryl family, the green color of emeralds comes from traces of chromium and vanadium. While they're softer, with a Mohs hardness of 7.5 to 8, their vibrant green color is unparalleled. They often have inclusions, referred to as the garden within the stone. Symbolizing rebirth and love, emeralds were cherished by ancient civilizations like the Egyptians. Amethyst, a variety of quartz. The purple color of amethyst arises from iron and other trace minerals. With a Mohs hardness of 7, amethysts are durable. Their color can range from light lavender to deep violet. Historically, amethysts were believed to prevent intoxication and have been associated with clarity of mind. Opals formed from rainwater that seeps into the ground. Opals are composed of silica spheres arranged in a grid. Opals are softer, with a Mohs hardness of 5.5 to 6.5. Their play of color is due to the diffraction of light off the silica spheres. Often considered a stone of inspiration, opals are believed to enhance creativity. While these are just a few of the many gemstones that adorn our world, each carries its own story, shaped by the forces of nature and human history. Their properties, from hardness to color, are a testament to the incredible interplay of chemistry, physics, and geology. As we move forward in this course, we'll delve deeper into the world of gemstones, understanding their formation, evaluation, and significance in various cultures. Whether you are looking to buy a piece of jewelry, embark on a career in gemology, or simply satiate your curiosity, knowing the properties and stories of these popular gemstones is a step in the right direction. As we venture into gemstone history, we will focus on the profound cultural significance of gemstones across different civilizations and eras. The ancient Egyptians held gemstones in high regard. Lapis lazuli, for instance, symbolized the night sky and was believed to provide protection. Cleopatra's favorite gem was the emerald, representing fertility and rebirth. The Romans believed that gemstones had powers to heal and protect. Red gemstones like rubies were associated with passion and power, while sapphires were symbols of wisdom and purity. In the Bible, the breastplate of Aaron is described as having 12 gemstones, each representing one of the tribes of Israel. The Book of Revelation also mentions various gemstones to describe the New Jerusalem. In Hinduism, the Navaratna, or the 9 gems, play a significant role in Hindu astrology. Each gem corresponds to a planet, and wearing the right gem can bring about positive changes in one's life. Throughout history, monarchs and royalty have adorned themselves with gemstones not just as a display of wealth, but also as symbols of power, divinity, and authority. The British crown jewels, for instance, are replete with gemstones, each carrying its own story and significance. In Australian Aboriginal legends, opals are believed to be the creator's footprints on Earth, imbued with the rain's colors. Ancient Greeks believed that this gemstone could prevent intoxication. The word amethyst itself means not intoxicated in Greek. Today, gemstones continue to hold cultural significance. Birthstones, for example, are gems associated with each month of the year, believed to bring luck and protection to those born in that month. Diamond engagement rings, a tradition popularized in the 20th century, symbolize love and commitment. Similarly, other gems like rubies and sapphires are often gifted as tokens of love, celebrating anniversaries and special moments. The cultural significance of gemstones transcends their physical beauty. They are carriers of stories, beliefs, and traditions, intertwining the Earth's history with human civilization. As we wear or admire a gem, we're not just looking at a piece of mineral, we're connecting with a legacy that spans millennia. As we continue our exploration in gemstone history, we will shine a spotlight on some of the world's most famous gemstones and the captivating tales that surround them. The Hope Diamond, weighing in at 45.52 carats, this deep blue diamond is renowned for its rare size and exceptional clarity. Originating from India, the Hope Diamond has a long history of ownership, from King Louis XIV to being stolen during the French Revolution, and eventually finding its home at the Smithsonian Institution. Legends say it carries a curse, bringing misfortune to its owners. The Koh-i-Noor diamond, meaning mountain of light in Persian, this 105.6-carat diamond is one of the largest cut diamonds in the world. With a history spanning over 5,000 years, The Koh-i-Noor has been fought over by various rulers and dynasties. Today, it's set in the British Crown Jewels, though its ownership remains a point of international debate. The Star of India, one of the world's largest gem-quality blue star sapphires, weighing 563.35 carats. Discovered in Sri Lanka, this gem is famed for its visible star pattern. In a daring heist in 1964, it was stolen from the American Museum of Natural History in New York but was fortunately recovered. Black Princess Ruby. Despite its name, this gem is not a ruby but a large spinel weighing roughly 170 carats. This gemstone's journey traces back to the Spanish royalty and the Moorish kingdom. It got its name from Edward of Woodstock, the Black Prince. Today, it's set in the imperial state crown of England. The Cullinan diamond, the largest gem-quality diamond ever discovered, weighing an astonishing 3,106 carats in its rough state. Found in South Africa, the Cullinan was gifted to King Edward VII. It was later cut into 9 major stones and 96 smaller ones, with the 2 largest pieces becoming part of the British Crown Jewels. The La Peregrina pearl, one of the most famous pearls in the world, with a history spanning over 500 years. Discovered in the Gulf of Panama, this pearl passed through the hands of Spanish kings and queens. In modern times, it was owned by actress Elizabeth Taylor, who famously lost it in a hotel but later found it in her dog's mouth. Each of these famous gemstones is not just a marvel of nature but also a testament to human history, passion, and desire. Their tales intertwine with wars, love stories, thefts, and royal intrigues, reminding us that gems are more than just beautiful objects. They are carriers of our shared human legacy. As we continue our exploration in the science behind gems, we will delve into the fascinating geological processes that give birth to the gemstones we so admire. Gemstones are nature's marvels, formed over millions of years under specific conditions. Their formation is a testament to the dynamic and ever-evolving nature of our planet. Gemstones formed from the cooling and solidification of magma or lava. Diamonds, formed deep within the Earth's mantle under extreme heat and pressure, and then brought to the surface by volcanic eruptions. The rate of cooling determines the size of the crystals. Slow cooling results in larger crystals, while rapid cooling produces smaller ones. Gemstones formed from mineral particles or organic material that accumulates in layers and hardens over time. Opals, which are formed from the accumulation of silica-rich solutions that harden over time. These gemstones often contain inclusions or fragments of the surrounding material, giving them unique patterns and appearances. Gemstones formed under heat and pressure that cause existing minerals to recrystallize or transform. Rubies and sapphires, which can form from the metamorphism of limestone. The original mineral's composition, combined with the specific conditions of heat and pressure, determines the resulting gemstone. Gemstones formed from hot water solutions that emerge from the Earth's crust. Some emeralds and quartz varieties are formed in hydrothermal veins. As the hot water solution cools, minerals crystallize and grow over time, forming gemstones. Gemstones that originate from living organisms. Pearls, formed inside mollusks as a response to an irritant, and amber, which is fossilized tree resin. These gemstones offer a glimpse into the interplay between life and mineral processes. The formation of gemstones is a complex interplay of chemistry, physics, and geology, shaped by the ever-changing dynamics of our planet. Each gemstone, with its unique formation story, is a testament to the wonders of nature and time. As we continue our exploration in the science behind gems, we will unravel the captivating science behind the vibrant and varied colors of gemstones. The allure of gemstones often lies in their mesmerizing colors. But have you ever wondered what gives a ruby its rich red or an emerald its enchanting green? Let's dive into the science behind these hues. When light strikes a gemstone, various interactions occur: absorption, transmission, and reflection. The colors we perceive are a result of these interactions. Different wavelengths of light correspond to different colors. A gemstone absorbs certain wavelengths and reflects others, determining its visible color. Trace elements or impurities within a gemstone's crystal structure can influence its color. Chromium gives rubies their red color. Iron and titanium can give sapphires a blue hue. Even minute amounts of these elements can have a profound impact on a gemstone's color. The arrangement of atoms within a gemstone can affect how light is absorbed and reflected. The unique structure of opals causes them to diffract light, producing a play of color. Diamonds have a crystal structure that reflects and refracts light, giving them their sparkle. It's not just the composition, but also the arrangement of atoms that plays a role in color. Idiochromatic gems. These gemstones are inherently colored due to their essential chemical composition. Peridot is naturally green due to the presence of iron in its structure. Allochromatic gems. These gemstones get their color from impurities or external factors. Pure quartz is colorless, but the presence of impurities can turn it into amethyst, purple, or citrine, yellow. Defects or imperfections in a gemstone's crystal lattice can create color centers that influence color. Exposure to radiation can create color centers in diamonds, turning them green. Amethyst's purple hue can be attributed to color centers involving iron. Techniques used to improve or alter the color of gemstones. Heat treatment can intensify the blue of sapphires. Oiling can enhance the clarity and color of emeralds. While enhancements can improve appearance, it's essential for them to be disclosed in the gem trade. The vibrant world of gemstone colors is a blend of nature's artistry and intricate science. As we appreciate the beauty of these gems, understanding the science behind their colors adds another layer of admiration and wonder. As we continue our exploration in the science behind gems, we will delve into the realm of modern gemstone enhancements, shedding light on the techniques that elevate the beauty and allure of our beloved gems. While nature gifts us with stunning gemstones, human ingenuity has found ways to enhance their appearance, making them even more captivating. Let's explore the world of modern gemstone enhancements. Enhancements can improve a gemstone's color, clarity, and overall appearance, making them more marketable and appealing. It's crucial to disclose any enhancements to potential buyers, ensuring transparency in the gem trade. Exposing gemstones to high temperatures to alter or improve their color and clarity. Sapphires and rubies are often heat-treated to intensify their colors. Amethyst can be heated to produce citrine. This is one of the oldest and most common enhancement techniques. Using lasers to drill tiny channels into a gemstone to reach inclusions, which can then be bleached or vaporized. Commonly used in diamonds to remove black inclusions. The process can improve clarity but might leave minute drill holes. Filling surface-reaching fractures or cavities with a substance to improve a gemstone's appearance. Diamonds with fractures might be filled with glass-like materials. Emeralds often undergo oiling to fill fractures and enhance transparency. The fillers can sometimes be detected under magnification and might require special care. Slowly heating and cooling a gemstone to alter its color. Topaz can be turned blue through annealing. The resulting color is stable and doesn't fade over time. Exposing gemstones to radiation to change or intensify their color. Diamonds can be turned green or blue. Pearls and quartz can also be color enhanced through irradiation. The process is safe, and the gems do not remain radioactive. Introducing coloring agents at high temperatures to penetrate the surface of a gemstone. Sapphires can be given a more vibrant blue or created with a star effect using diffusion. The color is usually limited to the outer layer, so recutting or scratching might reveal the original color. Modern gemstone enhancements are a testament to the blend of nature's beauty and human innovation. While these treatments can elevate a gem's appeal, ethical practices demand full disclosure to ensure that enthusiasts and buyers are well informed. As we continue our exploration in the science behind gems, we will introduce you to the essential tools of the gemological trade. These instruments, both simple and sophisticated, empower gemologists to study, identify, and appreciate the myriad wonders of gemstones. Gemology, while rooted in science and history, is also a hands-on discipline. The tools we'll discuss today are the bridge between theory and practice, allowing gemologists to interact directly with the gems they study. The jeweler's loupe, a small, portable magnifying glass used to inspect gemstones. Ideal for observing surface features, inclusions, and overall clarity. Typically offers 10x magnification, and it's an essential tool for any gemologist. The microscope provides a more detailed view than the loupe, with higher magnification and lighting options. Used to study inclusions, surface features, and even the growth patterns of gems. Some microscopes are equipped with dark field illumination, highlighting features otherwise invisible. Refractometer measures the refractive index of gemstones, a key property in gem identification. By placing a gem on its flat surface and observing through the eyepiece, one can determine its refractive index. Different gemstones have distinct refractive indices, making this tool crucial for identification. Polariscope used to determine the optical character of a gemstone, whether it's singly refractive or doubly refractive. A gemstone is placed between two polarized filters, and its behavior under polarized light is observed. Helps in distinguishing between similar-looking gemstones. Spectroscope, a device that separates light into its spectral colors, revealing the absorption spectrum of a gem. Useful in identifying certain colored gemstones based on their unique spectral patterns. Both handheld and desktop models are available, with the latter offering more detailed results. Dichroiscope shows the two pleuraoic colors of a doubly refractive gemstone. By viewing a gem through the dichroiscope, one can observe its pleuraoic colors, aiding in identification. Especially useful for stones like tourmaline and iolite, which display strong pleuroism. Chelsea filter, a color filter that helps in distinguishing genuine gemstones from imitations. When a gem is viewed through this filter under a light source, it may appear a specific color, aiding in its identification. Commonly used to differentiate between natural and synthetic emeralds. The world of gemology is vast and intricate, and these tools are the gateways to its deeper understanding. As we progress in this section, we'll delve into hands-on exercises and demonstrations, ensuring you not only know about these tools but also master their usage. As we continue our exploration in the science behind gems, we will guide you through the foundational tests and evaluations that every budding gemologist should be familiar with. These tests, when combined with the tools we discussed in the previous lecture, provide a comprehensive approach to gemstone identification and assessment. Before diving into the specifics, it's essential to understand that gemstone testing is both an art and a science. While tools and tests provide data, the interpretation of this data requires experience, intuition, and knowledge. Visual inspection, the initial assessment of a gemstone using the naked eye or a jeweler's loupe, helps identify surface blemishes, inclusions, and the overall quality of the gem. Often the first step in gem evaluation, providing a general overview before more detailed tests. Specific gravity test, a test that measures the density of a gemstone, comparing its weight in air to its weight in water. Different gemstones have distinct specific gravities, aiding in their identification. Requires careful measurement and a calibrated scale for accuracy. Hardness test assesses a gemstone's resistance to scratching. Using the Mohs scale, which ranks minerals from 1, softest, to 10, hardest, gemologists can determine a gem's relative hardness. Helps distinguish between gemstones and their imitations, as genuine gems often have characteristic hardness values. Refractive index measurement, as discussed in the previous lecture, this test measures how much a gemstone bends light. Using a refractometer, one can determine a gem's refractive index, a crucial factor in its identification. Some gemstones may have similar colors but different refractive indices, making this test invaluable. Fluorescence test observes how a gemstone reacts under ultraviolet light. Some gems glow or change color under ultraviolet light, providing clues to their identity. Commonly used to identify diamonds, as many diamonds fluoresce blue under UV light. Magnification and microscopy, using a microscope to observe a gemstone's internal and external characteristics. helps identify inclusions, growth patterns, and other microscopic features. Offers a deeper insight into a gem's formation, treatments, and authenticity. Spectral analysis using a spectroscope to observe the unique pattern of light absorption in a gemstone. Each gemstone has a characteristic absorption spectrum, aiding in its identification. Especially useful for colored gemstones, revealing details about their chemical composition. Gemstone testing and evaluation are foundational skills in gemology, bridging the gap between theoretical knowledge and practical application. As you hone these skills, you'll develop a keen eye and a deeper appreciation for the intricacies of each gemstone. As we prepare to conclude this enlightening journey, let's take a moment to reflect on what we've learned, the skills we've acquired, and the doors that have now opened for you in the world of gemology. We began our journey by diving deep into the enchanting universe of gemstones, understanding their allure and significance throughout history. From the geological processes that give birth to these radiant stones to the cultural tales that have been woven around them, we've explored the multifaceted nature of gemology. Through hands-on assignments and interactive lectures, you've gained both theoretical knowledge and practical skills, equipping you to appreciate and evaluate gemstones beyond their sparkle. Understanding gemstones is not just about identifying pretty stones. It's about appreciating the intricate dance of nature, science, and culture. Whether you're looking to buy jewelry, work in the gem industry, or simply enhance your general knowledge, this course has provided a solid foundation. For those looking to delve deeper, consider pursuing formal gemological certifications. Institutions offer advanced courses and certifications. With your newfound knowledge, doors open in the jewelry industry, gemstone trading, museum curatorship, and even gemological research. For many, gemology remains a passionate hobby. Continue to grow your collection, attend gem shows, and join gemological societies to connect with like-minded enthusiasts. The world of gemology is vast and ever-evolving. New gem deposits are discovered, new treatments are developed, and new scientific insights emerge. Stay updated by reading gemological journals, attending workshops, and participating in online forums. Gemology, at its core, is a celebration of nature's wonders. As you continue your journey, remember to approach each gemstone with curiosity, respect, and wonder. Behind every sparkle lies a story, a history, and a world of knowledge waiting to be discovered. Thank you for joining us on this luminous journey. Whether you are taking the first steps in a gemological career or simply satiating a personal curiosity, we hope this course has ignited a lifelong passion for gemstones. Remember, the world of gems is as vast as it is beautiful, and this course is just the beginning. Keep exploring, keep learning, and let the world of gemology unfold before your eyes.